Hello, this is Goofer King Science, and today we'll be doing the copper cycle experiment. Pause the video and look at the supplies you'll need for this experiment. First, I'm going to describe all the steps in this experiment. Please note that these equations are not balanced. I'm also sorry that I'm not able to do subscript numbers, as that's not supported by my editing program. To begin, copper metal is reacted with nitric acid to form copper nitrate, which is a light blue color. Also, brown nitrogen dioxide gas is formed. Next, the copper nitrate is reacted with sodium hydroxide, forming a dark blue precipitate of copper hydroxide and soluble sodium nitrate. Now the copper hydroxide is decomposed using a heat source. This will form dark black copper oxide and water. Now the dark black copper oxide is reacted with hydrochloric acid to form copper chloride and water. The copper chloride is a light green color. Finally, the copper chloride is reacted with zinc metal. This forms zinc chloride, and then the copper metal that we started out in the beginning of the reaction with should precipitate out. Now it's time to actually perform the experiment. First, weigh out half of a gram of copper powder and put it into a 150 milliliter beaker. Now add 10 milliliters of 6 molar nitric acid. This clip is sped up 4 times, and it takes a little bit for the copper metal to start reacting, but pretty soon the nitrogen dioxide gas begins to form, as you can see. Now it's really getting going. I forgot to video it, but once this is done reacting, you need to dilute it with 10 milliliters of distilled water. You can see the light blue copper nitrate that is formed. Now add 20 milliliters of 6 molar sodium hydroxide to the copper nitrate. You can see a dark blue precipitate of copper hydroxide. Stir this up to make sure that it's all reacted. Test this with red and blue litmus paper to make sure that it's basic. The blue litmus paper should stay blue, and the red litmus paper should turn blue, indicating we have a basic solution. Now set up a ring stand with a metal ring and a wire gauze so that we can set the beaker with the copper hydroxide right on top. Light your Bunsen burner and begin heating the copper hydroxide. After a little bit, you should begin to see it darken as it decomposes into the copper oxide. I'm using a wash bottle to get all the copper hydroxide off the sides of the beaker. Now that a lot of copper oxide is beginning to form, the solution is quite dark. Here's the finished product. Now I'm going to perform a vacuum filtration to retrieve the copper oxide. Put the Buchner funnel into a 3-prong clamp over a 150 milliliter beaker and slowly add 20 milliliters of 3 molar hydrochloric acid to it. You can mix this up with a stir rod. What's happening is the copper oxide is dissolving into copper chloride. The copper chloride formed is a bright green color. You can use a pipette to place some of the copper chloride solution back into the top of the Buchner funnel if all the copper oxide didn't dissolve in the first addition. Next you need to weigh out 1 gram of zinc powder. Now add this to the copper chloride solution and it should begin to bubble and react. What's happening is the zinc is more active, so it's taking the place of the copper metal and forming zinc chloride. As you can see, the copper chloride color is going away and becoming clear. Now what's this? Oh look, the copper that we started out in the beginning with is right back where we started it with, in the bottom of a 150 milliliter beaker. We can perform a vacuum filtration. There's the copper we started out with. I weighed this and it was 0.461 grams, but I lost about 0.04 grams during this experiment.
Now you can talk.
Can we talk?
Yeah, you can talk.
Alright.
I just added the nitric acid.
So you go in then and you'll put sound over the top of this.
Yeah, I'm gonna voice over like now you add the 10 milliliters.
Oh, good color there and everything. Now get ready to get the dark. You might turn it so that this white thing is the other direction,
Yeah.
so they can see the
nitrogen.
So are you into videos too, Roy?
No.
No?
Well, he has a YouTube channel, but he does games and stuff. So.
I did? Oh, that's cool.
I have not posted a video in a long time, though.
Haven't you?
Wow.
There, we can see the brown gas starting to form.
You want to take a picture of Rory inhaling it?
Yeah.
And laying on the floor, twitching. Frothing at the mouth.
Oh, now it's really going.
This is Rory, 2 hours later.
Think that's good?
Yep.
Thanks for watching. One thing I'd like to say is, recently I've been learning chemistry from a professor at the local college, and he's allowing me to make videos in their laboratory, and that's why I'm working in a real lab in this experiment. And you can see that I have access to all kinds of equipment and chemicals that I could never even have dreamed of having access to in my home laboratory. So thank you to them for letting me use their facilities. I'll be doing more videos in the future at that laboratory, so please subscribe so you can see those awesome experiments.